What about the hard drives that most of us use to store our data? They form the core of a computer's memory. Every day, they record massive quantities of digital data thanks to a technique that is both ingenious and precise. A hard drive consists of a set of circular platters that revolve at high speed. The rotation of these disks create an airflow maintaining the read head at an infinitesimal distance from the surface.
Relatively speaking, this corresponds to a Concorde flying at full speed 1 meter above the ground. You can see that the smallest chalk, the tiniest piece of dust, which is large in relation to the distance between the head and the platter, will be catastrophic. Once the head has touched the platter, the hard drive is dead because the head is stuck to the platter via molecular bonding.
Hard drives are vulnerable to shock and are not entirely safe from dust and impurities. Manufacturers therefore cannot guarantee them for more than 5 years. Do the flash memory in our cameras and USB flash drives offer a more reliable alternative?
USB flash drives, SSDs, as well as the flash cards used in cameras, for example, raise another problem in that they have a finite number of read-write cycles. The number of read-write cycles is quite large, up to 100,000, but in computer systems, these 100,000 cycles are reached fairly quickly. If, however, you use a USB drive, an SSD, or a flash card for archive purposes, in other words, you record your data on it and then store the device, then it's entirely possible to keep the information for a dozen years. A
life expectancy of 5 years, 10 years, 20 years. Mankind has never in its history stored so much information on such fragile media. Will we be able to store our digital memory for more than a century, let alone several millennia? This question has already arisen in certain sectors that have already started to archive sensitive data. ANDRA, the French National Radioactive Waste Management Agency, stores thousands of barrels filled with more or less active nuclear waste in its storage sites and concrete blockhouses. Each barrel is marked with a barcode identifying the digital file that contains the data vital to the site's archives. In order to contain the dangerous radioactivity, the barrels must be stored securely for 300 years. Where will digital technology be in 3 centuries? Will a system capable of reading our current media still exist?
There's really no issue with digital per se. The problem is that it's a kind of endless screw that we're not sure we can keep turning ad vitam aeternum, because digital often changes standards, becoming increasingly compact. For example, those 5-inch floppy disks we used 20 years ago, you can't find a single machine to read them today. So you have to migrate your files to new media, maybe even with new software every 10 years. And this endless screw, it's hard to be able to guarantee that in 1,000 years we will have been able to keep it turning. So we will have to develop parallel solutions to make sure that in the long term, data is transmitted where we want it to be.
What media was therefore selected to back up digital methods and offer fairly reliable, secure storage to withstand this test of time? ANDRA opted for old friends, paper and ink. Today we have permanent paper without any added bleaching chemicals. They do not deteriorate over time. The data is printed using acrylic ink that is extreme in the long term. The paradox is instructive. Over the period of a century, digital does not compare with paper, which we have had since ancient times. The most radioactive waste requires another timescale. Andra intends to bury, at great depths, the radioactive materials that will only stop being a risk in 500 years, and for some, 5,000 years. Throughout this entire period, we need to know where they are buried in the storage conditions at all times. A solution appeared while excavating the 1,400 meters of galleries for the underground laboratory.
For very long-term memory, if we think in terms of many millennia, one of the ideas we are exploring is to use what we call dump sites. In other words, areas where we place the material excavated from underground. Geologically speaking, this material should not be found in the places where it will be, and we are thinking of placing within these dump sites a certain number of inscriptions on media that are currently under study to explain to future archaeologists, future geologists, why this geological material is in a place it shouldn't be, thereby indicating the existence of a storage site.